The law of cosines. When two sides and the angle included between the two sides are known, side angle side, or when three sides are known, side side side, we can use the law of cosines to solve the triangle. If the three sides are known, always find the largest angle first, because when you're solving the triangle, if you want to use the law of sines to finish finding the rest of, or solving the rest of the triangle, you could get a wrong answer if you don't find the largest angle first. So this is the law of cosines. In any triangle ABC with sides A, B, and C, the following hold. All of these are the same formula. We're just using different letters depending on what angle we're looking for or what angle we're given. So let's solve a triangle using the law of cosines. In triangle ABC, if side A is 9.47 feet, side B is 15.9 feet, and side C is 21.1 feet, then solve the triangle. So since we need to solve, we're given three sides, and because when we're given three sides, if we're trying to find an angle, we need to find the largest angle first. The largest angle is always across from the longest side. So since this is the longest side, side C is the longest side, we need to look for angle C, which means we need to use this form of the formula. All right, so let's just plug the information into the formula. Okay, so side C, which is 21.1, I plug that in, squared, is equal to side A, which is 9.47 squared, plus side B, which is 15.9 squared, minus 2 times A times B times the cosine of C. So we're trying to solve for angle C. We need to isolate C or get C by itself, but we need to make sure that we follow order of operations when we're trying to solve this. So remember, in order of operations, before we do any addition or subtraction, we need to do the exponents, and then we also need to do multiplication or division. So here is an exponent that needs to be raised to a power, and then these two terms are being raised to a power and being added. So we can raise them to a power and add those together, and we can do that all in one step. But we cannot subtract it or subtract this part because it is connected to the cosine of C. So that is not a like term. So we're going to do these three things separately in our calculators. Okay, so we're going to square 21.1, which gives me 445.21. And then we're going to square the 9.47 and the 15.9 and add them together all in one step, which gives me 342.4909. And then I'm going to multiply the 2 or negative 2 times 9.47 times 15.9. And that gives me a negative 301.147 cosine of C. All right, so like I said, these two terms are not like terms because that last term has the cosine of C connected to it. So I need to get my like terms together. I need to move this over to the other side of the equation. All right, so that's what I'm going to do. So I'm subtracting 342.4909 from both sides of the equation, and that gives me 102.7191 equals negative 301.146 cosine of C. Okay, so to get C by itself, to get rid of that negative 301.146, I need to divide both sides by the negative 301.146. Now, I wouldn't put this part in my calculator just yet because anytime we're doing something like this, we don't want to round, and if I put this part in my calculator right now, I'm going to get a really big decimal, so I would need to round to be able to take the cosine inverse of it. So I wouldn't put that. I would leave this just like this. Okay, and then to get rid of this cosine on the C, I need to take the cosine inverse. Okay, so I'm going to take the cosine inverse of both sides of the equation. So now this is what I would put in my calculator. Cosine inverse of 102.7191 divided by negative 301.146. And that's going to give me what angle C is. Okay, so when I put that in my calculator, I get 109.94 is my angle C. Make sure that, or 94 degrees, that's my angle C. Make sure that your calculator is in degree mode and not radians. Okay, so now that I have found one of my angles, I can find my other angle by using the law of sines, which is a little simpler than using the law of cosines. And so I have a complete proportion, or a complete side of the proportion. I have side C and I have angle C. So it doesn't matter which of the other two angles I look for now. Let's just look for angle A. Okay, so if I'm looking for angle A, if I set up the law of sines, sine of A over the side of A, which is 9.47, would be equal to the sine of C, which is 109.94, divided by side C, which is 21.1. Okay, so then remember to solve using the law of sines. I'm going to cross multiply, and I'm going to take sine inverse. So to get A, let's see, to get A is going to be sine inverse of 9.47 sine of 109.94 over 21.1, and that gives me that angle A is 24.96 degrees. Okay, so I have angle C and angle A. Of course, I was given all three sides, so the only part missing to solve this triangle is angle B. And since we have two of the angles, we can find the third angle by subtracting from 180. So if I subtract angle C and angle A from 180 degrees, that leaves me with 45.10 degrees for angle B. And now we've solved this triangle. Two roads intersect at an angle of 102.1 degrees. Your friend's mailbox is 476 feet from the intersection, and your mailbox is on the other road that is 615 feet from the intersection. How far apart are the two mailboxes to the nearest foot? Well, first of all, let's picture what they're saying. If this is our intersection, and this is the angle of the intersection, let's say that this is your friend's mailbox right here, and it is 476 feet from the intersection, and your mailbox is 615 feet from the intersection. So the question is, how far apart are the two mailboxes to the nearest foot? Okay, so we're looking for this distance right here. Okay, so they didn't label any of these parts, so we can label these however we want to. So let's just say that this angle is angle C. So if that's the case, we're going to be looking for side C. All right, I'm going to say that this is angle A, so that means that this would be side A. So this is angle B, and this would be side B. Okay, so we are not going to use the same, or we're not going to set it up the same way that we did in the last problem, because we're not given three sides. We're given a side, the included angle, and another side. But we still have to use the form of the formula depending on what angle we're given. Okay, so if we're given angle C, we're going to be using this formula, but instead of looking for angle C, we're looking for side C. Okay, so this is how we would plug this in to the formula. We're looking for C, and that's going to equal A, which is 615 squared, plus B squared minus 2 times A times B times the cosine of C, which is 102.1. Now, this is easier to solve than when we were looking for the angle, because to solve for C, we can put this directly in our calculator. Now, the only one other step is that C is being squared, so we need to take the square root of both sides of the equation. So we can take the square root of all of this, and if we just put that all in our calculator at one time, then we get that side C is 800, and it says to the nearest foot. So we're going to round this. 800 is 852.9, so that would round to 853 feet is the distance between the two mailboxes. Now, if we were trying to solve this triangle, then we could go on to use the law of sines to find the missing angles, but we answered the question that they're asking here, how far apart are the two mailboxes, and it's 853 feet. So we're done with this problem. One more thing that I would like to talk to you about is finding the area of a triangle. If side angle side is given, then we can find the area of a triangle by using these formulas. Just like in the law of cosines, these are all the same. It just depends on what information we're given. But it's the angle that we're given, or the sine of the angle that we're given, and it's being multiplied times the product of the other two sides, and we're taking half of it. Okay, so that's if we're given a side and the included angle. If we're given all three sides, then we use Heron's formula. And in Heron's formula, we plug in all the sides as A, B, and C, but we also have to have S, which is called the semi-perimeter, or half the perimeter. And so all we do is we take A, B, and C and add them together and divide it by 2 to get S. A real estate agent wants to find the area of a triangular lot of land whose sides are 52.1 meters, 21.3 meters, and the angle between the sides is 42.2 degrees. They didn't label any of these as A, B, C, so on, so it doesn't matter which form of the area formula we use. So let's just look at it like this, and we'll call our angle A, and our sides B and C. Okay, so if we want to plug this into this area formula, we're looking for the area, and that is equal to half of side B times side C times the sine of the angle, which is 42.2. All right, so that can just be plugged directly into our calculator. Again, make sure that you are in degrees and not radians. And if so, we get that the area is 372.7 meters squared. We're in areas, so our meters, the area is always in square units. All right, find the area of the Bermuda Triangle if the sides have the approximate lengths of 850 miles, 925 miles, and 1,300 miles. Round to the nearest whole number. This time we're given all the sides, so we're going to have to use Heron's formula. And if we're using Heron's formula, we need to find S. All right, so S is just half of the perimeter, so S is 1/2 A plus B plus C. Okay, so that would just be half of all of these sides added together. And we get that S is 1,537.5 feet. Okay, so now Heron's formula is this. So now that I have S, I can plug all of this into the rest, or all this information into the formula. Okay, so it's 1537.5 times, and then I'm going to subtract each of those sides from S and multiply them together. All right, didn't quite have room there to be able to write it all out, but I can put that again directly into my calculator, and if I take the square root of all of that and I round to the nearest whole number, I get that the area is 392,129 square miles.